Hi everyone, here are video solutions for 13.3. We're going to do 3, 13, 15, 17, and 18. Starting with number 3, the directions say find the length of the curve, and the curve is given as r of t equals root 2 ti plus e to the tj plus e to the negative tk, and we're told to find the length of the curve between 0 and 1. Okay, so we know that our length function is the integral from a to b of the magnitude of r prime of t dt. So first we're going to find r prime. So r prime of t is the function root 2 e to the t and negative e to the negative t. And then the magnitude of r prime of t is the square root of root 2 squared, so 2 plus e to the 2t plus e to the negative 2t. Picking up from here, we're going to try to find a common denominator to clean this up a little bit. So this is the square root of 2 plus e to the 2t plus 1 over e to the 2t. And then from there, I'm going to write this as the square root of 2e to the 2t over e to the 2t plus e to the 4t over e to the 2t plus 1 over e to the 2t. Okay, let's pick it up from there. So we've got the square root of e to the 4t plus 2e to the 2t plus 1 over e to the 2t, which gives us the square root of e to the 2t plus 1 squared over e to the 2t, which when we square root is e to the 2t plus 1 over e to the t. Dividing that gives us e to the t plus 1 over e to the t or e to the negative t. I don't necessarily expect you to be able to do all of that simplification. You could basically just go to the calculator probably from step number 1 there, but just wanted to show you where it comes from. So our arc length is 0 to 1, the integral from 0 to 1 of e to the t plus e to the negative t dt, which is e to the t minus e to the negative t evaluated from 0 to 1, which is e minus e to the negative 1 minus 1 and plus 1. So this is e minus e to the negative 1. And that's our answer. Okay, number 13. All right, reparameterize the curve with respect to arc length, measured from the point where t equals 0 in the direction of increasing t. Oh, sorry. Okay, so our function is r of t equals 2t, 1 minus 3t, and 5 plus 4t. Okay, in order to do our function for arc length, we're going to go like this. So in order to do that, we need r prime. So r prime of t is 2, negative 3, 4. And the magnitude of r prime of t is the square root of 4 plus 9 plus 16, which is root 29. Okay, so we're going to do, oh wait, where are we parameterizing from? Oh, from the point where t equals 0. So it's s of t equals the integral from 0 to t of root 29 du, which means we've got an answer of s of t equals root 29t. So t equals s over root 29. And if we substitute that back in to the original function, we'll have a new parameterization, which is based off of arc length. So it would be 2 times s over root 29, 1 minus 3 times s over root 29, and 5 plus 4 times s over root 29. Okay, 15. Suppose you start at the point 0, 0, 3 and move 5 units along the curve x equals 3 sine t, y equals 4t, and z equals 3 cosine t in the positive direction. Where are you now? All right, so this is a reparameterization problem in disguise. So if we're moving 5 units long, we want to basically find r of s, and then once we have r of s, to evaluate r of 5. So we need to reparameterize in terms of arc length. So to do so, let's write the function r of t as 3 sine t, 4t, and 3 cosine t. We'll need its derivative, which is 3 cosine t, 4, and negative 3 sine t, and we'll need its magnitude. So that's the square root of 9 cosine squared t plus 16 plus 9 sine squared t. And 9 cosine squared and 9 sine squared makes 9, and 9 plus 16 is 25, so this thing ends up being 5. So s of t is the integral from, let's see, 0, 0, 3. Yep, that's the point when t equals 0. So it's the integral from 0 to t of 5 du, which leads us to the fact that s of t equals 5t. So, okay. Good. That's correct. Okay, so then t equals s over 5. So if we rewrite r in terms of arc length, you will have the function 3 sine s over 5, 4 times s over 5, and 3 cosine times s over 5, or cosine of s over 5. Subbing in now 5 to that gives us 3 sine 1, 4, and 3 cosine 1. That's where you would be. That's the point where you would be after traveling 5 units along the curve. Okay, 17 is next. All right. So it says, find the unit tangent and unit normal vectors, use formula 9 to find the curvature. So here's, I think, where I'll try and do this by hand, and if it gets messy, then we'll go to the calculator. So r of t equals t, 3 cosine t, 3 sine t. Okay, so we're going to ignore unit normal vector. We're not going to do that. So part A, unit tangent vector. That's r prime of t over the magnitude of r prime of t. So r prime of t equals 1, negative 3 sine t, and 3 cosine t. The magnitude of r prime of t is the square root of 1 plus 9 sine squared t plus 9 cosine squared t, which is root 10. Okay, so unit tangent vector would be the vector 1 over root 10, negative 3 over root 10 sine t, and 3 over root 10 cosine t. That part's done. Okay, now B, use formula 9 to find the curvature. If you look back in the text a couple of pages, formula 9 is the one that we left off on in class, so it's this one. It's the magnitude of t prime of t all over the magnitude of r prime of t. Okay, so let's compute the magnitude of t prime of t. So first we need t prime. That's 0, negative 3 over root 10 cosine t, and negative 3 over root 10 sine t. So magnitude would be 0 plus 3/10 cosine squared t plus 3/10 sine squared t. Oops, mistake. That should be 9/10, I think. Just check my work here. T prime. Magnitude of t prime. Yes, that's right. 9 and 9 sine squared t, which gives us the square root of 9/10, which gives us 3 over root 10. Okay, so the magnitude of t prime is always 3 over root 10. So our curvature is 3 over root 10 divided by root 10. We had that from before, right here. So that gives us an answer of let's see, 3 over root 10 divided by root 10 or times 1 over root 10 gives us an answer of 3/10. So the curvature of that helix is always 3/10. Cool. Okay, 18 might be a little more ugly, so we might want to do that one by calculator, but I'll try and do it by hand. Okay, so r of t equals t squared sine t minus t cosine t and cosine t plus t sine t when t is greater than 0. Okay, r prime of t is 2t cosine t minus cosine t plus t times negative sine t, and negative sine t plus sine t plus t cosine t. That simplifies a bit. 2t, and then t sine t, and t cosine t. So that's r prime. And the magnitude of r prime of t is square root of 4t squared plus t squared sine squared t plus t squared cosine squared t, which is just the square root of 4t squared plus t squared, which is root 5 times t. Okay, that's not so bad. So big T of t is the function. Let's see, if we're doing 1 over root 5t out in front of here, right? That's going to be out in front of there, 1 over that. So we would have, sorry, I need a minute to think here. 2 over root 5, that's our first term. Then 1 over root 5 sine t, and 1 over root 5 cosine t. All right, that's part A. We did the unit tangent vector. We're going to not do unit normal vector, and we are going to do curvature. Okay. So for part B, curvature, we need t prime. So t prime of t is 0, 1 over root 5 cosine t, and negative 1 over root 5 sine t. The magnitude of t prime of t is the square root of 1/5 cosine squared t plus 1/5 sine squared t, which is 1 over root 5. So curvature, remember, is magnitude of t prime of t over magnitude of r prime of t. T prime of t, where was there? Magnitude of r prime, where was that? It was root 5t. Okay, so here's what we have. We got 1 over root 5 divided by root 5t. So we can treat that as 1 over 5t. Cool, that cleans up really nicely. Okay, I think we made it through.